This is the Python segment where I discuss mathematical equations in the course ME 760. I'm presenting this because I will provide only partial code this week, and you have to pay attention what I'm building here and reproduce as part of your assignment this week. And as you can see here, we're going to use the Crump's formula, and the formula is basically a protection against having total cancer risk going above 1, which makes no sense because it's a probability. Probabilities cannot be higher than 1. So cancer risk equals 1 minus e to the power of the sum of individual cancer risks. So here, I already imported the libraries, as you can see from here. I also defined that we're going to use 100 points. This is just so we have a nice looking graph. What we are going to do then is, I'm going to create the risk numbers as if it was individual cancer risk in the x-axis. I can call it risk or I can call it x. I'll call it x for now for simplicity, equals, and I'm going to create a vector numpy using linspace, and it'll be from 1 to 5, and we're going to use n points, which I already indicated is 100. Now I will create a vector with all the e raised to the power of a number, such that for each one of the cancer risks, we know what the number is. So here we have ye equals np dot exponential numpy exponential x. And here I also would like to create a line that is y equals 1 for any number of x's. So what I do is, I'll call it just y1 to serve as a reference for us when we plot the graph. And p dot ones and points. So what it did was, it creates 100 numbers in y1. Each number in the vector is equal to 1. And now to create the vector, I will say y graph, why not, equals np dot linspace, again the linspace, np linspace from 0 to 5 and points. We're going to sum all the risks, individual risks. So here I'm going to do, I'll say sum equals 0 so I can start counting, or I'll just say IC as a I counter in range 1, 2, and points. We did this many times. You will have to do this by yourself. The code is not being provided. I provide the skeleton with importing the libraries, but this is not. So put all your focus on this. Sum equals sum plus ye of the counter. So say for the graph, it's going to be yg IC equals 1 minus 1 point divided by sum. Remember, it's 1 divided by sum is the same as e to the minus whatever the sum is. So I'm doing this step by step. I'm not summing within the exponential. What I'm doing is I am creating a vector. They have summations as I go, what is the risk as I go up, as if the sum was already done. And here, I'm done with the summation. So now I can just say print risk sum equals sum. So I'm going to print such that I can see it. And I say print using Crump's formula equals 1 point minus 1 divided by sum. Why not? Print Crump's equals yg of n points minus 1. And this is a little more complex than you writing this when you're doing your homework. Now I prepared all the plot routines and you will have access to this. I don't want you getting confused or bogged down by the plotting routines. So if I click run, what happens here is the editor changed my variable from x to xand. And you have your graph, and you can see this is the y1 line that I wrote. The variable is y1 right from here. And the plot, as I add more and more higher numbers that themselves are higher than 1, just to prove the point. Each individual point, it is as if the summation inside the exponential was already bigger than 1, but it will not go beyond 1 no matter how high I make the numbers. This is it for this week. Assignment using Python and the explanation of the mathematics of the Crump's formula. Thank you very much.